Hi everyone, welcome to Community Friday by Menlo. I believe this is our fourth call. So good morning or good evening, depending on where you're dialing in from. So today we would like to start things a bit differently, a bit of a structure. So I would like to maybe structure this a bit, mostly for our internal team actually. So today we would like to show you something that we shipped. So how did we make the robot better today? Stuck, what are we still figuring out? And we would also love to show you some of the stuff that we've been working on, because it's been very exciting 2 weeks at Menlo here. So we have a lot to show. And for the agenda, we will roughly go through this order. So first we'll have software, and then we'll go through the hardware part, and then some of the housekeeping, some of the internal updates, and career opportunities from Menlo. First, I think I can pass over to Yuki, right?
Right, yes. I'm very excited to show you guys what we've been working on. So we have been working on the Menlo platform. So for the past few weeks and months, you guys probably see a lot of updated on the physical Asimov. So today we want to talk about the virtual one. Yeah. So we are currently developing the Menlo platform, which is supposed to help serve the virtual Asimov, and then like everyone can basically own one as if it's like the real one, and you can experiment with it or connect the agent to it. So I just want to go through a bit on what we have done. Yeah. So upon logging in, you can, let's say, select an environment. Today we will probably go with the apartments, and then let's open up the cockpit of Asimov. Yeah, so first when you guys go in, you can see the agent log on the right side, and the reasoning trace also, then also all the email log on the left side. So this is like all the data that we take from all the joint photo of the robot in the simulation, and we just start streaming on the left side over here. Yeah, just gonna start the robot now. Yeah, so we actually done a lot of iteration on how to make this possible. You probably see a lot of like demos of simulation in the browsers online already, so it's not like magical or anything. But what we would really like to offer is like a much more high details, much more complex scene in the browsers experience, right? So to do that, it's not very feasible to put that in the browsers. So a lot of this, what you're seeing right now, is actually the physics engine running in our servers. Only the animation is done on the browser side, right? So let's go through a bit on the manual mode first. So you actually can control Asimov manual mode as if it's like a game, right? Let's try to give it a command. Just now I turn right, now turn left. Let's walk through space a bit. Yeah, you can see on the right side on top, there's like a first person view. This mimic where the Azimuth camera gonna be, which is in the head. Yeah. And let's go back to the starting point. Okay. Oops. Yeah, so what you guys seeing right now is like real locomotion policy running on the Azimuth, right? Being trained by Azimuth team, we just provide like the full physicality of it. And now the interesting part is we're gonna try the Asian mode, right? It's still process like a work in progress, but it's quite interesting, yeah, to see how an Asian will interact with the environment when they have embodiments, right? Hi, can you see the doors on the left? Can you move to the left side of the doors over there and like try to close it? Yeah, so we have like an Asian loop running, and then you're just trying to see from the first person view, what do they see, what should we do next. You can see all the reasoning state down here, and then like the conversation log is like on the right side, right? Yeah, but we're still working on the Asian. That part is hard. Like there's a lot of trial and errors that's being done here. It's like how many frames you want to send from the robot to the agent so that you know the history, you know the context, like, or like how's the heartbeat gonna be, like all this designing, like all this fine tuning is what make kind of like the magical moment when an agent can control a robot. We're still working on it. And in the future, in the near future, hopefully, we would really want to allow everyone in the community to plug in their own agent also, so that they can so that you guys can experiment with like how an agent would work in the environment, like in a physical environments, right? And like help us advance the state of agent embodiment together. Yeah. So that's the state of the Menlo platform right now. A lot of our R&D actually is spent on making sure that like we can serve a lot of people on our infrastructure, like all the physics agent on our infrastructure, while like doing the while like you can still see it on your browser and rendering nicely and smoothly and all of that. Yeah. Okay. So that's all from me. Would love to have question from you guys. Sorry, TechMax, what do you mean by frameworks? So everything you see here is actually built in-house. The physics engine is Mujoko, but other than that, everything else we built in-house. So including the rendering part, which we would love to be able to open source one day, so like everyone can, test out with it also. Yeah. Is there an API you can plug this into our own table operation? Yeah, definitely. So if you go to the menu mode over here and you go click down, right, you actually see we right now have keyboard. We actually have a CLI, so you can actually do like Menlo robot forward, Menlo robot backward. We figure out like if we provide this, it will be quite easy for you to plug in like a clock code or codecs or whatever to like sort of like just control a robot. And we also have like a Menlo robot snapshot, which take a snapshot of the screen. Sorry, not a screen, snapshot of the robot camera also, so that like you know where it is. Oh, sorry, you can pan it around. So yeah, I hope that's how does spatial navigation work. Good question. We are still figuring that part out. Right now, we are sort of like generating like a mini map of the environment from the Mujoko, from the Mujoko simulation, and like use that as like kind of like a way to navigate around the map. But honestly, a lot of this is like up to research. That's why we would love to have more people joining our platform to test out their own spatial framework for like AI, if that makes sense. Yeah. No, actually, this is just pure fitting. So we are okay. Are you using SLAM for navigation? No. We actually just purely feeding in the first person view camera you guys seeing there. The agent is just figuring out the rest. Yeah, there's no SLAM at the moment, but we would love to be able to include that, maybe like a basic depth anything or something feature that will just do segmentation and depth in the platform itself. Yeah. Yeah, you can see the agents kind of fail here, but it's just yeah. Okay, is there any other question? Yeah. That's the idea, right? We would love to have you guys plug your own agent into the platforms, right? So Orion is just a way for us to test agent control, and it's like a way for everyone to like have a reference design, right? So to how to like build agent on our platform. Yeah. Okay. Yeah. Thanks for all the enthusiasm. I'd love to bring this to you guys soon. Yeah. We will love to bring that soon. Yeah.
Please continue dropping your questions into the chat and we can respond to you there. But I think next up we can move over to hardware team.
All right, thanks, Mimi. So the last time we left off, our last community call, we mentioned that we were going to release some of you want, so now it's actually public. So far we've released the electrical schematics, the mechanical files, the assets, as well as the wiring diagrams for everything. If you can see here, we have small readmes in each of the sections to show you how to navigate the places as well. Currently, the manual does not have information on the electrical data, but that's coming soon. TBA probably sometime in the middle of next week. For the mechanical side, it's same as the legs over here, but we actually got a very helpful PR from the community to help consolidate some of the mechanical information. So I'm not sure if Abdel Slak is here in the call today, but thank you for this PR. I believe I understand what you're trying to do. I have some suggestions how we can improve it. And I really want to merge this into the main branch. As for the roadmap and what we're having in the future, the Asimov API, which is going to be a primary way for you to control the robot. So based on Yuki's previous presentation, what you saw there in simulation, the exact same API can be used to control the real robot. So this will allow you to go from developing applications in sim without having the robot and then directly deploying it. Of course, there might be some differences due to having real hardware, but the software API itself will be exactly the same. For the locomotion policy, Ishti will share more soon. And we're also working on a mobile app to make it easy for you to control the robot, not just for teleoperation, but just for basic turning on, monitoring, logging, agent-based debugging of the robot itself. Ishti, on to you.
Yes, I can share my screen. Yeah, so I'll start off with the video of the current state of the locomotion policy. And this week we were just trying to really stress test it and test it on different surfaces, test it without the crane to see what the failure modes will arise and what the edge cases will be with the locomotion policy. So as you can see, we are trying to move it outside our office here. We're just trying to see, does it get caught in the floor? How much is it leaning forward? How much drift is there? And so this is the locomotion policy. We are able to get it working on the robot after we got some hardware fixes. And as you can see, it's not perfect here, and the robot sometimes gets stuck or the robot's leaning forward. And so the main two issues we identified that we want to solve is one, the robot generally tends to lean forward. It could be that the policy learned a dynamic and we need to model something correctly to improve this, as well as you've not seen this video, but sidestepping was an issue. And so we were not getting determinism with sidestepping. Sometimes we would just wildly swing its leg. And so one way we actually rectified this is we went back to the XML and looked at, okay, are we modeling the collision boxes properly? Since Mojoko is all about collision boxes, it's just a contact physics solver. And so we realized that during a testing, we had actually changed the initial pose of the robot, but forgot to update the collision boxes. And you can see the arms are quite off. The toes are actually quite off as well. It gives the policy headroom to lean and like use its ankle roll so much, but in reality, it doesn't have that. And so after we rectified the XML and went back to a more aligned XML to the mesh, um, we were able to fix the sidestepping issue because the model is able to actually know how much foot room it has to be able to bend its ankle, so on. So this solved the sidestepping issue, but we're still solving the forward walking issue.
I think I go next. Or any questions about the previous part? Okay, then I just start first. Okay. So So we have some update about the menu, since I noticed some people asking about the battery and the hand. So just to be clarified, we don't include hand and battery in our Asimov 1 kit, but we do include some operation guide and also like what do you need to connect to the battery and the hand, for example. These are all the specs that you need to follow to build a battery that is suitable for the whole system, including the mechanical dimensions and the power capacities and also the charge current. Yeah, we do include the battery. Okay. We'll update this soon. I think there are some changes about shipping the battery. And also we include, as this is also in the electrical files in the open source GitHub repository, about how to operate and connect the motion control board. And you can see the mapping of connecting through the picture here, so you can connect it yourself to both the legs and like powers and etc. And about hand, we're not included here. So we have like 3 options for you to connect your hand. So like for power, you can connect either directly from the main battery, or you can connect through the wrist motor port. But just to be be considered that you have to have a converter to set down the power to the normal operating range, for example, like 5 volts, because the voltage of the battery is like 48. So, and also the communication option, we have 3. So you can either through the motion control board, which we will, which you have to upload to on script to control the hand, and also you can directly control through the Raspberry Pi, or you can use whatever communication board you have. And either way, you have to write your own script. We do have some recommended hands from Unitree by Hand and Dex Hand, and also Robotic and Okra Hand, which they open source. So you can take a look as a reference. Yeah, that's all for this update. Please share any feedback you have, or you can just go through the assembly steps and let me know if there's any step that you're confused, so I will add more information.
Oh, Ariel, could you get back to the battery section? I think we had a typo there on the manual saying the battery is not included. We're actually working to get certification right now so that we can ship a battery along with the rest of the parts for the robot. A charger will also be included. So out of the box, what you will get is a battery and all the components required to assemble the robot. So once you're done going through the assembly manual, you have a working ASIC.
Oh yeah, this is included in the steps that, like here, you can just install the same way as what the instructions is.
Yeah. Does anyone have any questions about anything hardware related, any software? How do you update the URDF? So currently the URDF update is completely manual. It actually just 2 days ago, we all sat around one computer and we moved each of the joints by like 0.01 until everything aligned perfectly. There's no good way to do this yet, but I hope as the robotics ecosystem matures, we get more automation tools for this. It doesn't make sense that I need to do this by hand. Actually, speaking of alignment, we're actually working on a way for you to home the robots. If any of you have used a 3D printer before, you know one of the first steps when a 3D printer boots up is that it moves all of the axes to the end positions, and this allows the machine to figure out, oh, what is the limits of my limits of freedom for the machine itself. And we want to have something like that for a humanoid, but getting it to work with a humanoid where you have some 360 joints, some joints like 270 degrees, can be quite dangerous. So we're figuring out a way to do this with end stops and just software. So sorry, just joining. I've moved away from ROS2 and using a custom Rust app. Are you guys on ROS2? No, we are not on ROS2. Our team has a slightly different stance. We don't like using ROS for things because we feel that it doesn't have a yeah, it's a trigger point. I'm being very politically correct here. But our stance on ROS is that we feel that it's an unnecessary abstraction if you actually understand systems programming. And we do have some very good system programmers on the team, so we prefer to use the abstractions below ROS itself rather than using ROS directly. We don't really have anything personal against ROS, but it's more of like only use what you need. For the BMS, we are getting it along with our battery pack. So it's not really a custom BMS, but it's a BMS from a contract manufacturer we're working with. So we're not actually building the battery pack ourselves. We don't really have the equipment or the knowledge to properly test a battery and a BMS. So we are outsourcing this part. But we are working with the contract manufacturer to get it certified with UN 38.3. Great job on the manual. The manual needs to have pictures for each of the parts because it is hard to see the IKEA diagrams without the part numbers. I see. So would you
I
like
see.
a colored picture?
So like for
Ariel, would you
each
like to go
module,
through
you wanna, yeah, let me do like for each module, you mean like you wanna like export the view of all the parts you need for the structure instead of just the names? Is that what you mean? Yeah, we can include that for sure. Yep, we will include that.
Oh, I adjusted. Yes, I hope your crowdsourcing goes very well. Okay, I don't think there's anything more from the hardware side. Mimi?
Yes, guys, please continue dropping any questions in the chat, or you can tag us on socials and then we'll get back to you. In the meantime, I think Herman has a lot of career opportunities to promote. Is that right, Herman?
Yes, that's right. Yes, so right now, let me share my screen. Yep. So we have quite a lot of opportunities open. We're hiring a DevOps, we're hiring supply chain associates, we're hiring firmware engineers, a forward deployed research engineer, embedded systems engineer, platform engineer. We're also hiring marketing specialists. If you're based in Singapore or you're open to working remotely somewhere in USA, we're looking for you as well. Right at the top of our list is also a marketing intern, someone to help us storytell what we're doing here at Menlo Research. And there are quite a number of other opportunities that you can check out on the website. So I look forward to receiving all of the applications and having a chat with each of you. Thank you.
Chat about what CAD we're using. So we actually use SolidWorks for all of our CAD. We have members in the team with experience in SolidWorks. That's why we chose it. It's also got very good URDF converters and URDF HTML converters. Sorry, not URDF HTML converters, but step assembly HTML converters, which is very nice for visualization. About triggering e-stop with software, actually, when the robot ships, the only way to trigger it will be via software. That's going to be the main way to control it. So it'll be connected directly to the motion control board, and there'll be a relay that you can trigger via GPI. So the goal is that it'll be similar to like a car, where you, if you've used most modern EVs, they usually have a companion app, and we're thinking about the robot in a similar fashion. And I think legally we can't call it an e-stop because usually e-stop means it cuts all power. What we do have is that we have a relay which switch off power to all the motors, but the compute stays running. So the robot won't be able to operate, but you'll still be able to collect logs and find out what actually went wrong during the entire operation. The RL policy. What would you like to know about the RL policy?
The RL policy we're currently using is just a normal PPO1. We will be releasing more information as to how we did SysID, how we solved the SIM drill in the coming weeks. But for the RL configuration or the model we are using, it's just a PPO for now.
There was a question on whether the e-stop can be triggered via software. Jishan, I thought that was a really good one.
Oh yeah, I covered it already. So to answer like very bluntly, yes, it will be able to be triggered via software. That's the whole goal. Go over what we're using power distribution. So for power distribution, because all the motors run on 48 volts, there's not much of an issue there. We just have a small bus out of XC connectors that allows you to distribute the power to all the limbs. And then for conversion, I'm currently working on a buck converter to convert the power down. In the current design, it's off-the-shelf version, but we would like to have our own so that it's easier to integrate into the entire robot. It's been giving us some trouble, so hopefully by the next Community Friday, I'm able to share more.
All right, any more questions? Have we seen anyone do humanoid teleop with a BCI yet?
That's a very interesting question. We have not tried it ourselves, but I have seen some people online attempting it. I think that's one of the endgame goals of Optimus and Neuralink. So for those of you who are unfamiliar with the acronym, BCI stands for Brain Computer Interface. So the idea is that you'll mount like electrodes and stuff onto your head or have an implant in your brain itself that allows you to control the robot. It's talked about like the end game for teleoperation. You basically go from thought to action instantaneously. So a question from Jay: why do you guys communicate over a single board computer to motor directly, not communicating with microcontroller to increase bandwidth? So it's not really to increase bandwidth, but currently each of our actuators, and the reason why we call them actuators and not motors, is that it already has a motor driver embedded into it. So there is multiple microcontrollers around the robot. I mean, 25 to be exact for each of the joints. So we don't really need the high frequency control loop that you get from a microcontroller. Instead, what we opted for is to use a full single board computer that can run Linux. So it'll give us some development velocity, makes it easier to OTA, and just development ease. And Linux drivers are pretty nice, especially when it comes to SpyCan and SocketCan. Yeah, Jachi, BCI teleop would indeed be awesome. Yeah, we've actually been trying to get, I mean, not trying, we have gotten VR teleoperation to work using the robot. But one of the problems we faced is that, I mean, it's the same problem with VR games, right? Is that you can get good hand operation if you're standing in place, but how do you handle movement, like squatting down, picking up stuff, and without you actually displacing in real life? So you need quite a big rig to do the whole full teleoperation. And it's quite actually quite uncomfortable to operate one because you're always slanting and stuff. I mean, you can always use a joystick, but your joystick is not getting full freedom, right? It's kind of like playing on a controller then. Let me see if there are any more comments. Is Mando here with us today? Mando and Grafto. They've been doing a lot of work to actually fabricate the robot. We were very impressed by your workshop, Mando.
Mando is in the chat. He's watching us. But you're a legend inside the company. Like, we talk about you. We're so excited.
Oh, okay. Hello there, Mando. So Babalaf is saying that Colonel will be interesting in partnering with you guys. He was very supportive in my 3 Hex project. Oh, that's amazing. We'll definitely reach out, or if they could reach out to us, either way is fine. Richard Franklin, I think you can get a squat with head tracking on the headset, right? Yeah, but it's also like the dynamic movement, like you're going down and like reaching for something far away. I think it's definitely possible to do. It's just it's a software engineering problem, which I like because it means that it's possible to do today. It's just a matter of how creative you want to be about it. So Baller Abdude is sharing his setup. I'm using 8-bit do mobile controller connected to my phone that sends teleop commands via a WebSocket connection from app to the Jetson board. Just an idea for you guys. Yeah, I think this is a pretty elegant way to go about it. Currently, what we're doing is that we just use keyboard teleoperation, but of course, you can connect any kind of hardware interface you want. And since we use LiveKit as our main way of bridging the robot to the outside world, it's just as simple as writing a LiveKit publisher.
Okay, I don't think we have any more comments or questions coming in. So again, please continue pinging us on socials, on our Discords, and we continue our conversations there. But otherwise, thank you for joining today. We'd love to have you here to watch us and follow us. So thank you for your time.